Good morning. I thought you forgot about me. I was about to leave.
What you mean?
Yeah. I was like, today's Tuesday, right? I don't know if it's extended holiday.
I need another holiday though.
Yeah.
Good morning, everyone. Good morning. Hope all is well. We got a few people trying to connect. Let's see. What are we supposed to be doing today anyway? Let's see, is everybody in? All right, so we finished out chapter 3 last class, I believe. Did anybody have any questions on anything? Anybody try anything, get stuck? Anybody?
I actually do have a question about like assignments and stuff.
All right.
When will we actually have our first homework assignment?
You said when we actually have what now? You're kind of low.
When will we actually have our first homework assignment?
Oh, they already posted in Math Lab.
Okay.
Yeah. So you can do those at your leisure. We're going to, I know I haven't set a due date for them yet. I don't believe. Let me check in there.
Because I go check and the little thing says no past your assignments, nothing, a current assignments, nothing. So.
All right, let's make sure you're seeing the same thing. We are seeing, so it's another class. Let me get in there. All right, so that's 1:30. So you click on assignments. And so there are your assignments right there. Hold up, no, yours should start. I got to go in the right shell. That was, you guys have a new shell. So it should start with chapter 2. So there we go. It should be. I didn't post this. I need to post. I thought I had posted it. Okay, I need to post a test that's after chapter 2, chapter 3. But test is supposed to pop up right here after 2 and 3. But that's what we've done up to this point. We did chapter 2 and chapter 3, and then there's supposed to be a test right here that talks about those 2 chapters. All right. So hopefully you're seeing that when you click on assignments. Yep. So did anybody have anything else? Any other questions on anything? Everybody good? Everybody straight? Let me take a picture.
I got one.
Yes, sir.
So I just missed the last question. I just popped my audio and my video and stuff on. I didn't see the test, but I took a few pre-tests and quizzes. Are those the ones in the assignments when you go up to the on the top left of the assignments board? It's got you can switch from homework to quizzes and tests. Are those the pre-test that you were talking about would add points to our?
No, that's what I just finished saying to them. That's what you're saying that you missed. I didn't post it. I thought I had posted it for you guys already. I'll post it before the night is out. I didn't post it. It's supposed to be a review, and then the actual test itself should have been a review for test 1, and then the actual test itself. So I need to post that. I thought I did that already. So my apologies on that.
When's that going to be due? Next class, next Thursday or this Thursday coming up?
Let's see if we look at a due date. So because when I talk about due date, we're talking about all of chapter 2's homework, all of chapter 3's homework, the review, and that test 1. So looking probably the 19th.
Okay.
For everything to be done. That should be a Sunday. So 11.
I done did all the homework.
Okay. Sounds good, sir. Sounds good. You're in a great position then. So yeah, so that'll put you guys in a good spot. Sunday, 11:59. And like I said, I'll try to post that test and review before the day is out. All right. So everybody's good. We can just do a couple sections and then everybody's straight. All right. So let's look at this next section. This is 10-1 for you guys. Ratios and percent. Hold on 1 second for 2% fraction. Where's proportion? Proportion should be in here somewhere. Okay, there we go. All right, cool. All right. So ratios and percent. So the ratio is the quotient. Quotient is division. Quotient of two numbers or two quantities. And it's no different from a fraction. So we have three ways that we can write a ratio. We have A to B. We'll write it out, A to B. We have A colon B, and then we have A over B as a fraction. And the fraction is normally how we would be using it or writing our ratio. Once again, we did switch books. So if you see something in your homework that you feel like I may have missed or not hit enough as far as discussion is concerned, let me know. It shouldn't be any difference. It shouldn't be that much, any type of real difference like that. But you never know. Sometimes things happen, things slip through the cracks. So just let me know. So directions for this first exercise, write as a ratio or write as a fraction. It says the ratio of 2 parts salt and 2 parts water. That's just 2/5. First part you see is your numerator. Second part is your denominator. So 2/5.
Will any question make us specify to answer these in each, like this one says write as a fraction. Would another question say write this as a something else? I don't know.
Or write using as a colon or don't believe so. I think the main thing is they give it to you in these first two forms and then tell you to write it as a fraction.
Okay.
Because that's the main way we're going to be using or setting up our ratios anyway as fractions. So like the next one is 12:18. So it's 12/18. And then we can simplify that to 2/3. Oh, excuse me. And then the next one, 2.5 to 3.15. Now I want to get rid of the decimal. Notice we have one decimal place here, that's tens place. We have two decimals here, that's the hundreds place. So at the most we have is 100. You can't multiply the top by 10 and the bottom by 100. You have to do, whatever you do to the bottom, you have to do to the top in order to keep your equivalency. So I need to multiply both of them by 100 to get rid of the two decimal places. And so multiply top and bottom by 100. That turns 2.5 into 250, 3.15 into 315. They both have 5 in them, so we can cancel out 5. So that's 50/63.
So you're not allowed to have a decimal in a ratio?
Not if you're going to write it as a fraction, because mathematically, this is not considered being in a fraction if it has decimals involved still. Yeah.
Okay.
Or it's just not a fraction in its simplest form. Probably the best way of saying it. All right, any questions on that? All right, proportions, a statement that two ratios are equal. 1/2 equal to 4/8 is a proportion. Cross product is what we will be using to help us solve proportions. So it just says if we had two ratios equal to each other, when you multiply each opposite denominator to each denominator to the opposite numerator, you take them up, make your x, you take your denominators up, the results should be equal. So notice over in the green, I have 1/2 equal to 4/8. If I take the denominator up to the 8 to the 1, that 8 to the 1, the 2 to the 4, multiply them together, 8 is equal to 8. So that sets up our proportion. That lets us know that we have a legitimate proportion. All right, any questions, any questions? So if we actually have a proportion, those products should be equal. All right, so they could ask us to solve this proportion. 45/x is equal to 5/7. So cross multiply. That would be 45 times 7, which is 315, x times 5, which is 5x. Divide by 5, and that's 63. All right, any problems? Next one, 3/8 equal to 63/x. Same process. Cross multiply. That'll give you 3x equal to 8 times 63, which is 504. Divide by 3, x is equal to 168. Any problems, any problems?
So anytime we see a problem like this, this is how they want us to solve this.
Yep, yep.
All
You
right.
can just cross multiply and then divide by the number that's attached to the variable. All right. So you may see one like this. But here we have x minus 5 over 3 equal to x plus 2 over 5. So once again, cross multiply, and that will create what we have right here, which is 5 times x minus 5, and then 3 times x plus 2. Then we can distribute 5x minus 25, 3x plus 6. Now we need to get our variables or our terms with the variables to the next side, to the left side, terms without variables to the right. So I'll subtract 3x from both sides. That gives me 2x minus 25. Then add 25 to both sides. 2x equal to 31. Then divide by 2.
If you would have, if you would have subtracted the 6 and put it on that side, what would that have done?
You talking about initially, like you talking about at what point, right? Oh, I still have my recent on my bad. Right at this point or right here?
That at that point.
All right, so let's go back. So now if you were to subtract 6 right here, now you're gonna subtract 6, you would have 2x minus 31 equal to 0. So then at some point you got to take either your x turn back over or take the 31 over. And then eventually you'll get here if you're still trying to solve for x.
All right.
But you'll have 0 on one side, and then you got to take something else to the right and then solve for x.
All right. Thank you.
Mm-hmm. All right. Anything else before we do another example?
So why won't you divide that 31 by 2?
Because it doesn't go into 31 evenly. So you can leave it as a fraction. Remember we talked about before, if you have a fraction, you don't have to convert it to a decimal or a mixed number unless it says so in the directions. So now if it was 32 over 2, then you would be expected, because 2 can divide into 32 evenly. But since the 31 cannot be divided by 2 evenly, you can leave it like that.
So it'll be the wrong answer if you went a step further.
No, not in this case. Now, let's say if it was 1 over 3, and that's 0.3 repeated. Now, if you were to put 0.3, then that would be the wrong answer, because it's not 0.3, it's 0.3 repeated. See, when you divide 2 into 31, that's going to be what, 15.5?
15.5.
Yeah. And that's a terminal decimal. It ends, so it's not a big deal. But if you had a run-on decimal, that's where you could be, could be a little problematic, because like I said, if you were to put 0.3 in for your answer, that answer would technically be wrong, because the answer is 0.3333 on to infinity. And if they didn't ask for that, then they actually could mark it wrong. So it just depends on what type of decimal you're going to have once you do that division.
Wow. Okay.
Yeah. So that's why I said, excuse me, that's why I said leaving it as a fraction is the safest bet.
On everything, no matter what, in this class.
Yes.
Okay. All right. Okay.
All right, everybody good before we go to the next one?
So I'm still
Mhm.
I'm still messed up, right? Because
Okay.
I'm looking at the bottom part of this 2x over 2, and then you performed that on that side,
Mhm.
but you didn't perform it on the other side. Like I mean, I understand that you're telling me to just leave it as a fraction. That's what it is. You know,
Mhm.
it is what it is. But like that's confusing, man.
Well, it's
To me.
performed. Now you got to shape your definition of what it means to be performed, because it was executed here and here, because we did do it. The division of 2 was there. You just didn't actually divide 2 into 31 and create a decimal, but that doesn't mean it's not there to, and it wasn't executed. You see what I mean? 2 was divided to both sides. Okay.
Yes, it
Now,
was.
on this left side, 2 divided by 2 was an even division, and it cancels out to give you 1. So that's why this is what's, in other words, that's the simplest way of expressing it. Now, when it comes to 31 over 2, writing it as a decimal doesn't necessarily fits every fraction as the simplest way of expressing it. Because once again, if I have a run-on decimal and I write 0.3, well, that's not the simplest way of expressing 1 over 3, because that's not even that answer, because that answer is 0.3 into infinity. So the simplest way of expressing this fraction is 1 over 3.
But
So
there's a way to express those infinite decimals, right? There's a way to express that, and
right.
I'm just used to, if somebody says simplify this or like, I'm just used to it, but I'm gonna do what you say. So I'm gonna let you go on. I'm sorry. I just wanted to clarify for myself. I'm sorry.
No, you're fine.
Everybody.
You're fine, because it might be a question that somebody else is asking, but we just have to reshape what your definition of, or what your definition is to be simplified. You see what I mean?
Even you were fighting back, saying the word perform on the
Right.
31 over 2 side.
Right, because I understand what you mean by perform, but sometimes when it comes to different things, especially when it comes to mathematics, our definition of certain things, of what we normally use, does not mean that that's not their definition of it. You see what I mean? And so sometimes we have to reshape our thinking just to fit the form of what they, when I say they, I'm talking about, the higher ups, whoever made this the answer. We have to reshape our definition. I had to do it myself. You know what I mean? You have to reshape your definition, because I understand exactly what you mean. So don't think I'm coming from like, nah, man, no. That's why when you said it, as far as the word perform, like, yeah, I get where you're going, but this is enough when it comes to mathematics, as far as it actually being performed, because now you give the right, like just like when you talk about pi. I was talking to the class, another class, about the word, the pi and what it represents. Pi represents 3.1415, I think it's 9, and then it goes on to infinity. Now, if you decide to rewrite that as 3.14, well, that's okay for you. But if I wanted to go further, once you perform your calculations, now I don't have a right to go further and be more exact than what you were. So it's almost like you creating a practice of giving the reader the right to be as exact as possible, versus you saying, okay, I'm gonna truncate it right here. You know what I mean? And I know that wasn't the case in this case, because this will give you a solid 15.5, but it's also setting a practice for other things. And you're setting a practice for higher maths. Because remember, this is foundational stuff. So there are times where the fraction is more beneficial than the decimal.
Okay.
You see what I mean? And so everything leads to something else when you're talking about algebra, because algebra is the foundation of all of your sciences, is the foundation of all of your maths. You can fail calculus because your algebra wasn't good. You know what I mean? So like this one guy said that his teacher failed him in calculus, and said that, you didn't fail calculus, you finally failed algebra. You know what I mean? So algebra is very, very foundational for like all of your sciences, all of your upper maths, and you're just setting those tables for those, really. And so that's where a lot of that stuff come from.
Okay, gotcha.
Yeah. Sorry, y'all, I ain't need to go on a rant on that, but he went there, so I was just trying to make sure everybody had understanding as to why. why we do certain things. Yeah. So sometimes it has something to do with a whole nother class, you know what I mean? So,
My calculus teacher would pick random questions for us to simplify and
mhm,
ones that she didn't want us to simplify,
mhm.
but we didn't know which questions to simplify. So we would have to go down and have a decimal version for one and then the fraction version for another one.
Oh,
And so if you
wow.
didn't have both, like you got the question wrong.
Wow. And see, and yeah, and that's all about, and I'm pretty sure that that person was prepping you for when you need the exact and when you need the approximation and stuff like that.
Yeah.
Yeah, because they do at certain times it's necessary and certain times it's not. And so you have to be prepared for multiple types of answers. Yeah. Mhm. All right. So the next one, on a map, 5 miles corresponds to 2 inches. How many miles corresponds to 7 inches? So whenever you have something like this, setting up your proportion, you want to make sure that you stay consistent in how you set up your fractions on each side of your equal sign. So if you do miles over inches on one side, you got to make sure you do miles over inches on the other side in order to keep your proportion correct. So if I have 5 miles to 2 inches, so I put 5/2. The next one, how many miles corresponds to 7 inches? So that would be X over 7 because the X represents miles. And once again, I got my miles over top of my inches. So with these type of problems, it's all about the setup first. Then once you have your setup, then you go ahead and cross multiply and divide like we did the other ones. So questions on the setup? Is everybody good? And what we did and why we did it? All right. Once you have your stuff set up, then you go ahead and cross multiply. All right. And so that one, I just went ahead and just did it. I think it might have been something that somebody else was asking for, and I just went ahead and wrote 17.5. Once again, if it's a terminal decimal, it's not a big deal. You know what I mean? But you do have to make sure that you hold true to the fact that, or make sure we have an understanding that if you had a fraction right, but then you go add an extra step, which you call yourself converting it to a decimal, and you write the decimal wrong, then the answer is going to be wrong, right? So you always want to make sure that hold true to the directions, eliminate as many steps as possible because we all are human. You don't want to make mistakes when you don't have to, and simplify your fractions as much as possible. But simplification does not have anything to do with your decimal.
So can you hear me?
I can.
All right. So on this one, you converted to a decimal because it makes more sense with the question.
No, what I was saying is that I think somebody else had asked me the same thing, going along the same lines that you had asked. Why not convert it to a decimal? And I was just letting them know that it's okay to convert it to a decimal. Just like I told you in the last one, it's okay to convert it to a decimal, but most of the time you leave them as fractions. And if they really wanted to be a decimal, they will tell you in the directions. Round to the nearest tenth, or round to the nearest whole number, or to the decimal, to the whole number, or hundredths, or whatever the case may be. And so going back here, once again, if I were to take that to 15.5, it's fine because it's a terminal decimal. But what happens is when we get into our flow, if it's not a terminal decimal and it's a repeated decimal and we truncate that or around it, but they didn't ask for it, then they reserve the right to mark it wrong. So that's what I was saying with that. If you have a run-on decimal and then they didn't ask for you to round it off at all, and they can mark it wrong because they didn't ask for that answer. That's not the answer. You know what I mean?
So which one would we get marked wrong for? The decimal or the fraction?
No. So let's say if the answer, going back to the 1/3, or let's go 2/3. 2/3 is 0.6 repeated, right? So let's say you get 2/3 as an answer and you write 0.67. They're gonna mark that wrong. You see what I mean?
Yeah.
Because the answer is 2/3 and 2/3 run on to infinity. Now, if you were to write this as 0.6 with the bar over it, if they give that option, then that would have been okay because that bar represents the 6 to infinity. But what they will mark wrong is 0.67. Or if you write 0.67, not 77, 0.667. Even though that's correct rounding, that's still wrong if they didn't ask for the rounding. Does that make sense?
Yeah, I mean, it made sense. It made sense before, and every time you explain it to me, it makes a little bit more sense.
Okay.
So it's just to eliminate my stupidity and my mistakes that I'm gonna make. They tell you to not go any further. Understood.
Yeah,
And I get that. I got you.
And it's not stupidity, sir. It's not stupidity. It's just going that extra step when you don't have to, or something like that. So ain't nothing wrong with it. All right. So let's do another one. The standard dose of antibiotic is 4 cc's for every 25 pounds of body weight. At this rate, find the standard dose for a 140-pound woman. cc's, cubic centimeters. So it's up to you if you want to do pounds over cc's or cc's over pounds. It's up to you. I decided to do cc's over pounds, but if you do that, make sure you keep consistent for both fractions. So the first ratio that they give is 4 cc's for every 25 pounds. So that's why I have 4 over 25. Then it says find the standard dose for a 140-pound woman. So in other words, your cc's is X. The 140 pounds is what's on bottom. All right. Any problems with your setup? Cross multiply. 4 times 140, 25 times X. And we can divide by 25, 22.4.
Can you scroll back up a little bit? I was writing down the question.
Sorry about that.
Thank you.
Is that good enough?
That's good enough.
Any questions? Any questions? All right. All right, are we good? I don't know if anybody's still copying. Everybody straight? I think that was the last one like that. Okay, that has nothing to do with you guys. Let me see. Do I want to do all those together? Percent notation, percent to fractions, all in percent. Notation, so it's 10, 2, 10, 3% problems. So 101, 7.1. So this is, let's see, it is 1143. We can do two of these. All right, so we'll do that another day. So let's do at least one more section. And so we'll go to 10.2% notation. I got 101, 7.1. All right, so let's look at percents and fractions and decimals. This is all under 10.2. As a matter of fact, look at one more thing, 130% notation, percent diffraction, solve percent proportions. That all may be under this one section. So let's see. All right, so percent, if you were to break down the word percent as per and then cent represents 100. So we're looking at per 100. So that percent sign, the percent symbol is going to represent 1/100 or 0.01 as a decimal. So it represents per 100. Per is division. And then, like I said, cent is 100. So it's per 100.
Can you scroll back up just a second? Thank you.
So don't write, excuse me, don't write the 7.1. Remember, we're in 10.2. Just percents, fractions, and decimals, though. All right, good to scroll up. Let me know how far. Okay, so the first thing we were looking at is converting decimals to percents. So we have 3 steps. First thing you want to do is locate the decimal. Then you go move the decimal 2 places to the right, and then you'll place your percent sign. Everything will always be 2 places when you're looking at percentage, because remember it's per 100. All right, scrolling up. Okay, so looking at 0.25, want to convert that decimal to a percent. So you just locate a decimal, we see it there in front of the 2 or to the left of the 2, and you move your decimal 2 places to the right, and then we place a percent sign, so it'll be 25%. $1.8, do the same thing. Decimal 2 places to the right. Now I notice that there's only one number to the right of the decimal, is 8, so we use 0 as a placeholder. So it's 180%. And then if we had the number 7, ordinarily you wouldn't see a decimal there, but they assume you know there's a decimal right behind the 7. And you move that 2 places to the right using 2 zeros as placeholders. That'd be 700%. All right. Any questions on decimals to percent? So no calculation, just moving your decimal to the right 2 spots. All right, gonna scroll up. So now we're looking at percents to decimals. We did decimals to percents. Now we're looking at percents to decimals. Once again, you locate your decimal. This time we're going to move the decimal 2 places to the left and remove the percent sign. All right. So 37%. So you're reversing the process. You move your decimal 2 places to the left. And that's just 0.37. 2.9%. Once again, move your decimal 2 places to the left. There's only one value to the left, so you will need a placeholder. So we'll use 0, so it's 0.029. And then for 0.6%, move it 2 places to the left, use 2 zeros as placeholders, 0.006 as your decimal. Any questions? Any questions? All right, let's scroll up. All right, let's see, percent diffractions. See if that's a new section. Fraction notation, probably 10.3. All right, so percents to fractions. So we're gonna replace the percent sign with 1/100. And we talked about when we initially, percent is going to equal 1/100. Then we'll multiply and simplify if possible. All right. So if we have 56% and we want to convert it to a fraction, so we're talking about converting percentage to a fraction, that percent we can replace with 1/100. And that's what we did right here. So that's 56 times 1/100. Then we can just multiply across 56 times 1 times 100. So that gives us 56/100. Then we recognize that both of them have 4 in them, so we can cancel that out, leaving us with 14/25. Any problems? So same type of deal here, 125%. Replace the percent with 1/100. You could reduce first if you like, but if not, just multiply straight across to give you 125/100. Then we recognize that 25 is in both numbers. 125 is 25 times 5, 100 is 25 times 4. Cancel out the 25s, and that'll leave you with 5/4. All right, 0.4%. So once again, replace that percent. Let's see, that percent sign with 1/100. Then multiply across. So that's 0.4/100. Now we talked about this scenario earlier, having a decimal embedded in your fraction. You do want to get rid of the decimal. So that 0.4 is in the 10th place. So you multiply top and bottom by 10. Remember, whatever you do to the top, you have to do to the bottom in order to keep your equivalency. So that 0.4 times 10 gives you 4. 100 times 10 is 1,000. Then we can cancel out the 4 that's in the top and bottom, leaving you with 1/250. Any problems? Can I scroll up? All right. So the next one, I think this is the last one in the section, I think. Fraction to percent. So we just did percent to fraction. This time we're doing fraction to percent. This one's a little easier, less work. Convert your fraction to decimal by division, then convert decimal to percent by moving it 2 places to the right. So, you can do that 3/5. Same thing as 3 divided by 5. Throw that in the calculator, or you can do it by hand if you like. That'd be 0.6. And so remember, if we have a decimal to convert to a fraction, a percent, move the decimal 2 places to the right, and that'll be 60%. So whenever you have a decimal, you always move your decimal 2 places to the right to convert it to a percent. Any problems? Any problems? All right. If we have 2 1/4, That 1/4 is 1 divided by 4, which is 0.25. That's what I try to point out right here. So 2 1/4 is 2.25. Move your decimal 2 places to the right, that would be 225%. Any questions? Any questions? Yeah, this should be it. So any problems? Anybody good? Everybody straight?
Yeah, can you hold up for 1 second on the last problem?
Mm-hmm.
I just want to keep up.
Yep, you're fine.
Now, can you talk through that last problem again?
Divide out the fraction, turn to a decimal. So you can throw that in the calculator. But if you want to do it by hand, feel free, of course. But convert it to a decimal and then move the decimal 2 places to the right. And that'll be it in percentage. So we had that point, you had 3/5, convert it to a decimal is 0.6. Move the decimal 2 places to the right, that's 60%.
Yeah, I get that one. The other one, the 2 1/4.
Okay. Yeah, so like you said, it's 2 1/4. So you're writing that as a decimal, that's 0.25. And so that's 2.25 because he had the 2 in front of it. So that's 2.25. And you move the decimal 2 places to the right, that's 225%. So all I was doing was emphasizing that right there, that 1/4 is 0.25 as a decimal, you know. And so
what if it's a problem where it's not so simple to be able to relate fractions to decimals? Say, what if it was like, I don't know. I don't know, something that wouldn't be like 3/7 or something like
put it in the calculator.
So just 2 divided by 7.
Mm-hmm. Yep.
And then the whole number goes.
So yeah, the whole number going.
The whole number stays. All right.
Yep. Yep. And if it's something that's a run-on decimal, they got to tell you something like, round to 2 decimal places or round to 3 decimal. They'll tell you that,
Okay.
But for the most part, they're probably going to use terminal ones so that you can do it without them saying the extra stuff. Yeah.
All right. Give me 1 second.
Yeah, you're fine. Take your time.
divided by 4. Turn my mic off.
Mm-hmm. Anybody else have any other questions while he finishes this off?
All right, I'm good whenever you are.
All right, thanks, sir. So that is it for today. Let's go back to our other page. So that really covers all percent proportions. That's 10-2 and 10-3. So we did 10-1, 10-2, 10-3. We'll start at 10-4. Next class, looking at solving percent proportions and going from there. All right. And
which one's 10-3? Yeah, which one's 10-3?
10-3 was percent to fraction, fraction to percent, percent to fraction. That last thing that we were doing.
So percent to decimal is all.
That should be 10-2. Yep.
All right, so 10-3 starts here.
Yeah, percent to fraction, fraction to percent. Should be 10-2. I mean 10-3, excuse me. All right.
And said all the tests and stuff are going to be open note, open book policy type deal.
Yeah.
Even the final exam.
What I'll probably do for the final is get you to have like a sheet, like a note sheet that you would create, and then
we have a test. So we have a test coming up.
Yep, for chapter 2, 3, it should have already been posted. Yes, class is dismissed. I didn't post it yet. I meant to post it this weekend, so I'll post it today.
Okay.
You'll see it in math lab. Yeah. So anybody else before we officially close? Everybody good, straight? All right. So if you guys are good, I am good. I'll see you next class. We'll pick up where we left off. If you have any questions, the floor will be open for you to ask those. If you try something, get stuck. Other than that, you guys have a good one. Be safe, and I will see you next class. All right.
Thank you, man.
Yep, no problem. Y'all have a good one.
Do the same.